Good afternoon, students. In the last class, we discussed about the projectile motion. So, projectile motion is one of the example for two-dimensional motion. So, one more example for the two-dimensional motion is uniform circular motion. So, this is also the example for two-dimensional motion, right? So, already we know motion. So, as the object displaces changes its position from one point to the another point with the time with respect to surroundings. So, that one we call as the motion. So, right now, what is circular motion, right? So, any object which follows the circular path for its motion, so then that motion we call as the circular motion, right? So, any object it follows circular path, right? So any object which it follows the circular path, then that type of motion we call as the circular motion, right? So here uniform circular motion, right? So uniform circular motion is the object is moving in a circular path with a constant speed, right? So that one we call as the uniform circular motion, right? So there is a change in, that means speed under to that of the velocity. So here the object is moving in a circular path with constant speed, not constant velocity. So there is a difference in speed and velocity, right? So here the object is moving with constant speed. That means at each and every point in its motion, its speed is always remains constant, right? So for example, if the object is moving with the speed some 5 meters per second, so calling this one as initial point. So after certain time it covers some point P dash, right? So here also its speed is 5 meter per second. So after some 10 seconds again its speed is same, right? So that type of the motion we call as the uniform circular motion, right? So if we define the uniform circular motion, so any object follows the circular path with constant speed, right? So with constant speed, so this gives what the definition of the uniform circular motion. So very important is the constant speed. That means at each and every point in its motion of the object, so the speed remains the same, right? So if we here in place of speed with the velocity, with constant velocity means, so there is no change in velocity. So if there is no change in velocity, that means the acceleration is zero, right? So here constant speed means the magnitude of velocity is constant, right? So velocity is a vector, right? So velocity is a vector. So this velocity has both magnitude plus direction, right? So in this velocity, the object which is moving in a circular path, it has a velocity. So this velocity has a constant magnitude, right? So velocity is, magnitude is constant, that means speed is constant, right? So but the direction is always changing. So as it changes from one position to another position, the direction of the object, that is velocity of the object, direction changes. So as the direction changes, then this object is moving with acceleration, right? So acceleration is change in velocity with respect to time. So change in velocity means if it changes the direction, then also we say that one as the object is moving with variable velocity, right? So if the magnitude remains constant, then the direction is changing means the object is moving with variable velocity. If the object having the same speed, that means magnitude of the velocity is same, but the direction changes. So if you observe here at the point P, the direction is in this direction. So after certain time T, it covers some distance, that is P dash. So it is the direction of the velocity in the upward direction, right? So again, somewhere here the direction will downwards, right? So in this direction the velocity is giving, right? So that velocity we call as variable velocity. So this variable velocity, either the speed may remains constant or it may be changes. So here in this case the speed is constant, that means its magnitude is constant, right? So we can say the two definitions for variable velocity, right? So direction remains same, the magnitude may vary. So in this case the magnitude remains same but the direction changes, right? So again from the definition of the acceleration is also the vector, right? So this vector again having magnitude plus direction, right? So as we define the acceleration, that is acceleration is equal to rate of change of velocity with respect to time. So velocity is changing. If the velocity remains same, that means the object is moving with the same velocity, that means the change in velocity is zero, then acceleration becomes zero, right? So here the direction is changing, that means we have the two different velocities. So magnitude may same, but the direction is changing. So hence we get the acceleration. So here in this topic we are going to find the magnitude and direction of the acceleration, right? So this is also very important for 5 marks. In board exam they ask for 5 marks. So this derivation is very important, right? So how we get the acceleration means the object is moving in a constant speed. That means it has a constant magnitude of the velocity, but the direction changes. As the direction changes, there is a change in velocity. So as it takes some time, so hence change in velocity with respect to time, we are getting the acceleration, right? So now we move on to the derivation, that is to find the magnitude and direction, right? So that is again by the method of vectors. So centripetal acceleration here we are going to find. So that acceleration we are deriving by the method of the vectors, right? So consider one particle which is moving in a circular motion. Almost it looks like a circle. If not means make this one as circle. So with center C and radius of the circle be taken as this one. Looks like circle, right? So little very okay. So taken C as the center of the circle and the object is moving at a radius from the center, that is at a distance r from the center, calling the initial point of the object taken as P, right? So after certain time, that is delta t. So in a small time, the object changes its position because the object is moving in a circular path, right? So the direction of motion is in this direction, right? So after certain time t, so object is somewhere here, right? So taken this point as P dash. So again, by drawing the position vector. So initial object is at P. So if I draw the position vector, Cp becomes vector R. So vector R denotes the position of the particle P, right? So after certain time delta T, the object is moved to the point P dash. So now here we are going to draw the position vector. So the object is P dash, so the position vector is R dash, right? So now by the method of vector law of addition, we are going to find the displacement because we want the acceleration. So acceleration is change in velocity with respect to time. So velocity is change in displacement with respect to time. So first we are going to find the velocity, then acceleration, right? So before that we are going to find the displacement, right? So the position of the P, the object is at P, then it displaces to P dash. So again by the vector law of addition, so R and R dash gives the position vector of the two particles, the two positions of the objects. So displacement vector is this one, that is delta R, right? So this is by the vector law of addition. So vector R plus delta R, that is equals to vector R dash. So we want delta R, that is equals to final position minus initial position. So this gives what? The displacement vector R dash, right? So the average velocity is in the direction of the displacement vector. So displacement vector is in this direction, then average velocity is also in this direction, right? So V bar represents what? The average velocity, right? So now we are going to find the instantaneous velocity at every point. So instantaneous velocity, how we finding it? Drawing the tangent at the point, right? So here at P, if I draw the tangent, so this gives what? V1 or vector V. So vector V gives what? It has the magnitude same, but the direction changes. So V gives what? The instantaneous velocity at point P, right? So same wise, the instantaneous velocity at P dash. Again by drawing the tangent to P dash, so here we get vector B dash, right? So now we need to find the average velocity, that is V bar, so the instantaneous velocity. So this gives what? The average velocity. Here we have the instantaneous velocity, right? So the change in instantaneous velocity we gives what? The acceleration, right? So by drawing the vector here, vector V. So again drawing parallel vector to V dash. So this gives what? Vector V dash. So again by the triangle of vector addition, we want delta V vector, right? So now the instantaneous acceleration is in the direction of the velocity, instantaneous velocity, that is V, right? This one as V vector, right? So if I draw the normal, so the direction of the acceleration is in this direction, right? So this one is the first case, right? So when the object is initially at P, after certain time, in a small time, it displaces to P dash, then here we are getting the average velocity. Average velocity is in the direction of the displacement. So next we are going to find the instantaneous velocity at every point. If we find the instantaneous velocity, that means by drawing the tangent to that point, so we get the instantaneous velocity of the 2 points, right? The change in instantaneous velocity we use what? Acceleration, because it also takes the same time. That means the centripetal acceleration, right? So we know the definition for the magnitude of the acceleration A, that is equals to limit delta t tends to 0, delta v divided by delta t, right? So this gives what? The definition of the acceleration. As limit t tends to 0, we get the delta v by delta t, right? So now if I write in the second case, only taken half part. So this is point P, where R is the radius of the circle, right? So at this point we have the velocity V. So this is the instantaneous velocity at the point P, right? So the direction of the acceleration is in this direction. So that acceleration we call as centripetal acceleration. That is always towards the center of the circle, right? So that means velocity and acceleration are perpendicular to one another, right? So this is the final representation to find the acceleration, right? So now here again we need to find the velocity in terms of the displacement. So considering two triangles, so naming C, P, P dash, right? So again here by taking the vector, so this we can take M, N, O. right? So remain, I will erase these two diagrams. So for derivation purpose, only considering one case, right? So considering two triangles, because this triangle is similar to the velocity vector diagram, right? So from triangle CPP dash and MNO. So as these two represents the similar triangles, hence from the similar triangles we can write the ratio of the sides of the triangle, right? So from this we can write this one taken as delta V bar, right? So delta V bar, so vector V divided by delta R. So this side is equals to this side, right? So this one is the displacement, change in velocity, and this one gives what, the change in displacement, right? So that is equals to, next one is the velocity, V divided by R, where R is the magnitude of the position vector R dash, right? So V, this length, that is ON divided by P dash, that is equals to Mn divided by OP, right? So this is the ratio of the change in displacement to the change in velocity, and the ratio of the sides Mn and to that of the PC, right? So ON, we write that one as delta V divided by delta R, that is equals to, so Mn is what, the vector V divided by OP, that is R. So here only taken the magnitudes, right? So you can write like this. So because here also we are going to find only the magnitude. So modulus of A means the magnitude, right? So here also we are finding the magnitude. So delta V divided by delta R is equals to V divided by R. So we need only delta V. So from that we can write delta V is equals to V divided by R into delta R, right? So now substitute this one. So calling this one as equation 1. So put equation 2 in equation 1, right? So now substituting second equation in the first equation, right? So we get the magnitude of the acceleration A, that is equals to limit delta t tends to 0. So in place of delta V, we can write V divided by R into delta R by delta t, right? So here velocity, instantaneous velocity, so this velocity is constant because the magnitude of the velocity remains constant, but the direction changes, hence V is constant and the radius of the circle is also constant. So we can take outside this one as V divided by R, limit delta t tends to 0, delta R by delta t, right? So again this gives what, the definition of the velocity. So instantaneous velocity is equals to limit delta t tends to 0, the change in displacement to the change in time, right? So we can write this one as V divided by R into V. So this is what, the magnitude of acceleration. So again here by the definition, V is equals to limit delta t tends to 0, delta R by delta t, right? So now we get the magnitude of the acceleration, that is equals to V square divided by R. So this acceleration we call as centripetal acceleration. So acceleration is always acting towards the center of the circle, hence we call that one as the centripetal acceleration, right? So this derivation is very important. So that is by the method of the vector law of addition, right? So first consider one circle, right, or an object which is moving in a circular path and it is at a distance r from the center of the circle. That means r gives what, the radius of the circle, right? So we use what? The object is moving with a constant speed. That means its value remains same. So velocity means magnitude of the velocity is same, or we can say the object is moving with a constant speed, right? So that means if we taken as velocity, then the magnitude of the velocity is constant, but the direction changes. That means variable velocity. We can also say that the object is moving with variable velocity, or we can also say that the object is moving with constant speed, right? So next, again, by the method of triangle of addition, first we need to find the position vector by drawing R and R dash. Then to find the displacement vector, again by the triangle of vector addition. So average velocity is in the direction of the displacement vector. So here we want to find the instantaneous velocity, right? So again, for that, to find the instantaneous acceleration, we need to find the change in instantaneous velocity at the point P and P dash, right? So for that we constructed a triangle. So here the both the sides M, N and M, O both are same because its magnitude is same. So magnitude same means the length of the vector remains same, right? So the direction of the change in instantaneous velocity is in the direction of the acceleration. So that acceleration is always towards the center of the circle, right? So now if we shift the points, that means if we decreases the velocities with respect to time. So if I consider any point somewhere here, the direction is like this. So here the direction like this. So that means drawing the tangent at that point we give what? Instantaneous velocity. So that change in instantaneous velocity gives what? The direction of the instantaneous acceleration, right? So now by shifting like this, when the time t tends to 0, we get the acceleration. So that acceleration is acting towards the center of the circle, right? So that acceleration we call as the centripetal acceleration. So you know, now previous class I explained what is why discussing the average velocity and average acceleration, and also instantaneous velocity and instantaneous acceleration. That means now time period ಜಾಸ್ತಿ ಇಂದ ಕಡಿಮೆ ಮಾಡ್ತಾ ಬಂದಾಗ ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಎಲ್ಲಿರುತ್ತೆ ನಮಗೆ ಇನಿಷಿಯಲ್ ಪಾಯಿಂಟ್ ಗೆ ನಾವು ರೀಚ್ ಆಗ್ತೀವಿ. ಸೊ ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಾವು ಟ್ಯಾಂಜೆಂಟ್ ಡ್ರಾ ಮಾಡಿದ್ರೆ ಸೊ ಈ ಟ್ಯಾಂಜೆಂಟ್ ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಏನಿರುತ್ತೆ ನಮಗೆ acceleration. So on the acceleration ಏನಂತ ಕರಿತೀವಿ ನಾವು centripetal acceleration, right? So again we need the change in velocity in terms of displacement, right? So for that, comparing the two similar triangles, that is one is displacement triangle and another one is velocity triangle. So again, if both the triangles are similar, so how we say that these two are similar means the radius is constant. So object is moving in a circular path at each and every point. The distance of the object from the center is remains same. So same wise, the object is moving with constant speed. So here also the length of the triangle is same because its magnitude remains constant, right? So now ivaga object some radius 10 centimeter circle alli move ಆಗ್ತಿದೆ ಅಂದ್ರೆ every point ಅಲ್ಲಿ ಕೂಡ from the center ಎಷ್ಟಿರುತ್ತೆ 10 centimeter ಅಲ್ಲೇ ಇರುತ್ತೆ. Same wise, the object is moving with some 5 meter per second speed, then throughout its motion, so its speed is same. So magnitude is what? The length of the vector, right? So illi kuda 5 centimeter, illi kuda 5 centimeter. So that means two sides are same, right? So two sides same is there, then angle is also the same, right? So for that we can say these two triangles are similar. So if two triangles are similar, so we can take the ratios of the sides, right? So we can take any one ratio, MO divided by CP dash, idunu tagobodu athwa MN by CP, right? So we can take the ratios of the triangles, then we get the delta V, that is equals to V divided by delta R. So as already said, the magnitude of the velocity is same and the radius is also the same, right? So we can take here common outside, right? So V divided by R. So this is from the definition again, the instantaneous velocity. So in definition now one dimensional study ಮಾಡಿದೀವಿ, in two dimensional ಕೂಡ study ಮಾಡಿದೀವಿ, right? So this limit delta t tends to 0, delta R by delta V, the delta t we can write that one as velocity. So this gives what? The instantaneous velocity, right? So V into V, we get V square divided by R, right? So where V is the instantaneous velocity. So that means the velocity of the particle at a particular time, right? So and R is the radius of the circle, right? So this is the derivation of 5 marks. So very important, several times. So only we have this much. So this diagram, then these 5 steps, right? So this gives what the magnitude and direction. So AC is the magnitude and direction is it always acts towards the center of the circle. So centripetal acceleration is always towards the center of the circle, right? So next. So this gives what the linear acceleration, right? So V is the linear velocity or tangential velocity. Acceleration is the tangential acceleration, right? So R is the radius of the circle. Now we have one more concept. That one is the angular displacement. So next one is angular velocity. Right? So here, what is angular displacement means? While the object is moving from one point to another point in a circular path, it makes some angle at the center of the circle, right? So this displacement, that is delta theta, we call the displacement, that is changing the position from P to P dash. It covers some angle, it forms some angle, right? So that displacement we call as the angular displacement, and it is denoted by delta theta, right? So what is angular displacement means? The object is moving from one position to another in a circular path. It makes some angle, right? So that angle we call the displacement, right? So that displacement we call as the angular displacement. And so here displacement is delta theta. So to change from one position to another position with respect to time, that is delta t, right? So changes its position, that is delta theta, with respect to delta t. So that one we call as the angular velocity, and it is denoted by omega, that is equals to delta theta by delta t, right? So angular velocity is denoted by omega, that is equals to change in angular displacement to the time taken. Now we are going to find the relation between the linear velocity and to that of the angular velocity and the centripetal acceleration in terms of the angular velocity, right? So we know the velocity v, that is equals to change in displacement. We can write one as delta s. Delta s is the change in displacement with respect to time taken. So small change in displacement to the small time taken, right? So here we have the angular displacement, right? So angular displacement is denoted by delta theta. So we are going to replace the linear displacement with the angular displacement, right? So for that, so this is the center of the circle. Initially the object is at P. After in a small time, it will move to P dash, making the displacement, that is angular displacement, delta theta. So where R is P dash will looks like a straight line, right? So this we consider as a straight line, right? So from that, tan delta theta is equals to opposite side by adjacent side. So this gives what the displacement, that is delta is the linear displacement, right? So tan theta is equals to, from the trigonometry, tan delta theta is equals to opposite side by delta s divided by the adjacent side, right? So that gives what? R, right? So we want delta s. So this is almost equals to theta. So delta s is equals to R into delta theta, right? So calling this one as equation 2. So this one as 1. So substitute 2 in 1. That means equation 2 in equation 1, right? So velocity v is equals to, so in place of delta s, we can write r into delta theta divided by delta t, right? So where r, the radius of the circle is constant, right? So keeping as is, that is r, and this term, that is delta theta by delta t. So we call that one as the angular velocity, right? So r into omega. This gives what? The relation between the linear velocity to that of the angular velocity, right? So where v is the linear velocity and omega is the angular velocity. So this gives what? The relation between linear velocity and to that of the angular velocity, right? So next, acceleration in terms of angular velocity, right? So we know centripetal acceleration AC is equals to v square divided by r, where v is the linear velocity, right? So here we get the linear velocity in terms of angular velocity, right? So AC is equals to, in place of v, we can write r omega whole square by r, right? So AC is equals to r square omega square divided by r. So r get cancelled. So centripetal acceleration is equals to omega square r. So this gives what? The centripetal acceleration in terms of angular velocity, right? So AC is equals to omega square divided by r. So these are the important relations. That is relation between the linear velocity. Linear velocity means the velocity in which the object is moving in a straight line. So either along x-axis or along y-axis. So that one velocity we call as the linear velocity. Angular velocity is the velocity of the object which makes some angular displacement, right? So this velocity of the particle consists of both the linear velocity and also the angular velocity, right? So next, time period. So two more definitions are there in this topic. So that is the first one is time period. So time period is denoted by t, right? So what is time period means? The object which takes time to complete one revolution. So that time we call as the time period, right? So for the complete one revolution, the object will take the time. So that time we call as the time period. That is time taken by the object to complete one revolution. Time period, right? So it is denoted by always capital T, right? So time taken by an object for complete one revolution, right? So for the complete one revolution, it takes some time, right? So either it may be 1 second, 2 second, 10 seconds. So that time we call as the time period for one revolution, right? So next one is the frequency, or we call this here as angular frequency, right? So frequency is nothing but the number of revolution will take in 1 second. That means for the time t is equals to 1 second, the how many number of revolutions it will complete in 1 second. The object will complete, either it may take 10 revolutions, 20 revolutions, or 100 revolutions. That is in 1 second, right? So that one we call as the angular frequency. That is the number of revolution will take in 1 second. It may be any number of revolutions, right? So the number of revolutions which takes in 1 second, so that one we call as the angular frequency, and it is denoted by nu or f. So we can denote by nu or f, right? So F that is equals to 1 divided by T. So this one is the mathematical relation. So frequency is inversely proportional to the time period, right? So if we define the angular frequency or frequency, so number of revolutions in 1 second, right? So the number of revolutions in 1 second, we call that one as the angular frequency. So time period is the object takes a time to complete one revolution, so that time we call as the time period, right? So now again from the time period, so time period in one object it covers one complete revolution, for that it takes some time, so that time we call as the time period, right? So as this one is the circular path, so by the definition we have velocity is equals to distance divided by time, right? So this is by the definition. So distance divided by time. To complete one rotation means it covers one circular path, that is circumference of the circle. That means the distance covered by the object is 2 pi r, where r is the radius of the circle, right? So the time taken for complete one revolution, so that one we call that one as the time period t, right? So now 1 by t we can write this one as 2 pi nu into r, right? So we can write 1 by t as f or nu, right? So this 2 pi nu into r, comparing this equation with the first equation, right? So this is also the velocity of the particle which is moving in a circular path, and also here we derive the velocity of the particle in terms of the angular velocity omega, right? So comparing these two, v is equals to omega r. So in the LHS, in place of v we get the v, in place of RHS, in the place of radius we are getting the radius. So this 2 pi nu is replaced by omega. So from this we can write angular velocity omega is equals to 2 pi f or 2 pi nu, right? That is equals to 2 pi nu, or that is equals to 2 pi divided by t. So this is one more relation, right? So angular velocity is equals to 2 pi f. So ಇದನ್ನ ನಾವು ತುಂಬಾ ಕಡೆ ಯೂಸ್ ಮಾಡ್ಕೊಂತಿದೀವಿ, ಸೊ ಇದನ್ನ ನೆನಪಲ್ಲಿ ಇರಬೇಕು. omega is equals to 2 pi f, right? That is equals to 2 pi nu. So nu we can write that one as 1 by t, right? So omega is equals to 2 pi divided by t. So in the same way we can replace AC in terms of frequency and time period, right? So now substitute the value of omega in centripetal acceleration, right? So AC we have the formula omega square r. Now substitute omega is equals to 2 pi f whole square into r, right? So we get centripetal acceleration AC is equals to 4 pi square f square r, right? So we can replace f by nu. As you are convenient, you can choose anyone, either nu or f, right? So in terms of time period, so AC is equals to, so in place of omega we can write 2 pi by t, that becomes 4 pi square by t square into r. So these are the few relations of angular velocity and centripetal acceleration. So in both the cases, the centripetal acceleration that is always towards the center of the circle, right? So by this we completed the topic, that is motion in a plane. So two examples for the motion in a plane are, that is uniform circular motion, and one that is the projectile motion, as we discussed in our last class, right? So in the next class we will solve the problems related to all these topics, right? Thank you.